All right. Math 4, hello again. We are now on to our last unit of the year, and I'm excited because this is my favorite one for this class. We're going back to Trig. EO7, again, intentionally done a little out of order for this online learning stuff. It's sort of the other half of Trig. Now, this is a very heavily modified version, so we're not going to be able to get anywhere near the depth that we normally would. That's okay. This question, do you know your unit circle, should seem somewhat familiar. I'm going to ask it a lot. Like, the whole question is predicated or based off of, like, the whole unit. Do you know that unit circle? Do you actually? And I'm serious. Like, do you know the unit circle? That's going to be critical for the success of this unit. We're going to basically cut any of the stuff where it would be super calculator based. We'll showcase, like, things that would need a calculator and kind of why. But everything we're going to do, at least that we're going to assess you on, is going to be unit circle based. Now, you have to know that, all right? So, today is May the 4th, sort of Star Wars Day, and I don't know if you know this about me, but I am a big Star Wars nerd. Found a sort of meme that happened to combine both. So, we got Ahsoka Tano here, so Ahsoka Tano. Small character from like some of the other like old school offshoot Disney cartoon things, but hey, there you go. We were able to do it. So this is the sort of problem that we're going to basically ask you to do. Okay, like when you see your quiz, it could be entirely reasonable that you see a question just like this: 2 cos x minus 1 is 0. Solve for x. And what does that mean? Okay, we're going to work our way back to this one by the end of the slides here. Okay, so what would have been last unit, but now 2 units ago, I should have put units, forgot to pluralize, we would ask sine of 5 pi over 6, and we're going to ask, hey, what is that value? So 5 pi over 6, let me think. If I do it this way, I'm used to doing it backwards. So 5 pi over 6 for you guys should be here. I have to do the actual normal version, I think. I'm trying to look at the camera and make certain this matches. Right, because this would be 0 from backwards. I don't know, but whatever. Unit circle, 5 pi over 6, you get half. We're going to now ask things like this. Where, basically, is sine equal to 1/2? 5 pi over 6 is an answer. There's also another place, pi over 6. Okay, just a quick sort of why that would be. If I were to draw, oh goodness, something like this, right? At 5 pi over 6, we're right here. That's where my half value is. But if I ask where is it half, it could be either one of these angles. We're going to play with that a little bit. I had to sneak one more in there. Well, A is pi r squared, V is pi r squared h, V is a cheap joke at R2D2. Anyhow, all right. We're actually done with the Star Wars stuff. Something like sine of x is 1/2. That's something we're going to be asking a lot of. And the reason is that's a known unit circle value. Half should be something that feels pretty familiar in terms of what you're used to seeing and us asking you in EO6. Sine of x equals 1/3 isn't something that we're necessarily going to ask, but you should know that it does at least exist, right? If there's a time where sine of x is 1/2, sine of x is 1/3 is going to be a little bit smaller of an angle. Sine of x is 4/3, that's something that doesn't actually happen, right? So the highest sine ever gets is 1, so this sort of thing right here would be a no solution. I'm just going to write SOLN, it's a pretty common thing you'll see in college. This needs a calculator, and then this guy is what we're mostly going to focus on with a known unit circle value, okay? All right. So let's start by asking what values make sense and how does the range of the function translate to a unit circle? I'm going to stress this again. Do you know the unit circle? You're going to need to. So if we just take a look at sine here, now this is only one period of sine, but if I were to basically continue extending this, we know that this pattern is going to basically just wave on in both directions infinitely. Oh, forgot to delete some old stuff here. So does every x have a y? Meaning if I go to any x value, do I go up and hit a y value somewhere? Absolutely. Does every y have an x? If I do sort of the inverse here, is that going to happen? Does every y value have an x? No, absolutely not. The range of this graph right here is between a 1 and a -1. Sine can only ever give me things between there. If I ask like where sine's equal to 2, that doesn't happen. my sine function is never going to spit out a 2. Keep that in mind. The range of this guy is going to be sort of restrictions for the questions we're going to ask. On a unit circle, we're used to sine being y over r. So when we say what y and r relationships are impossible, well, we just saw that the highest sine can go, y over r, the biggest it could get is 1. So it has to be less than 1, but it can equal 1. Or the smallest it gets way down here, or on the bottom of that sine graph, is a -1. So this is basically a fancy way of saying, hey, your sine function is going to be between a 1 and a -1 once you've done any sort of division. You got to sine. Oh no, I forgot angles here. Ooh, that's probably going to be on every slide. Forgive me for that. So you've got to have these pieces in mind, understanding what values your function can give, because we are going to ask questions where the answer could be very well no solutions. Cosine. Just like sine, it's going to be infinite in both directions, but it's capped at a 1 is the highest it can get to. Ooh, goodness, didn't hit that. And the -1 is the lowest it can get to. It can get any of the values in between those. So let's answer these two questions. Does every x have a y? Dogs, do we have to do this now? Does every x have a y? Yeah, if we pick any x value, you go anywhere along the x-axis here, you're going to hit some y value somewhere. Okay, we're just playing around now. We've got an upside down dog. Combs, you just hamming it up to the camera. OB just chilling. Tona's the white one. OB's the very, very little one there. And this is about the time of day where they start getting angry that I've been sitting at the computer all day. Okay, anyhow, back to the trig. Does every x value have a y? Absolutely. Does every y value have an x? Also, no. Just like sine here, we ask the same sort of questions now. What x and r relationships are impossible? Well, we know x over r, after we do all that division, has to be smaller than or equal to 1, and has to be greater than or equal to a -1. You can't get anything outside of that 1 to -1 window, right? My x value gets to 1 right here, and it can't go further, and the -1 is right here. I'm looking at this x value. Can't ever go further than that, right, as we're swinging around that unit circle. We're going to go through all 6 trig functions here, but we'll pick up the pace a little bit. Tangent. Here's a graph of this. Does every x value have a y? No. What if I go to right here? Pi over 2. If I ask for tangent of pi over 2, what would we say? That's a place where, if like we think on our unit circle, we're going straight vertical. That's going to be a 1 divided by 0. This is an undefined. I'm not going to write all that. So does every x have a y? No, it doesn't. Does every y value have an x? Right? This guy right here is shooting all the way up to infinity, and then this tail right here is shooting down to -infinity. I hit 0 right here. I can get any positive and any negative. This, no problem at all. So this one kind of flips from how the other guys go. There are times where tangent doesn't exist, so that's why does every x have a y? No. Does every y have an x? Yeah, right? Like as it goes closer and closer to these parts where it doesn't exist, it shoots up to infinity or down to -infinity. We kind of already answered this. What x and y relationships are impossible? If we looked at these two angles, pi over 2 and 3 pi over 2, these are going to be situations where when I did y over x, at these two angles, I would get undefined because right here I'm going to have a 1 divided by 0, and here I'm going to have a -1 divided by 0. You got to know the unit circle for this stuff. Cotangent. Basically kind of switches some of the order, shifts a little bit. Does every x value have a y? Well, if I go to like right here, looks like 0 right there, doesn't. Looks like, well, if that's 3, you can probably guess this guy right here is going to be pi. These are not very great straight lines. Yeah, there's multiple x values that don't have a y. So this answer, no. Does every y have an x? As I follow this, right, I can get anything all the way going up to positive infinity, or anything all the way down to -infinity. I can get any y value I want out of a cotangent, but it doesn't occur at every x value. So this guy is a yes. Does every x have a y? Is a no. If we went back to our unit circle, what x and y relationships are impossible? Well, now we're looking, these guys, oops. Yeah, this is right. I'm sorry. I got to go back to the tangent one. I messed this up. These are not the right values here. Those are the ones that we need for this other guy. I'm so sorry. Let's go back. Let's clean that up. Gotta know that unit circle. I made a mistake myself there. Places where y is 0 would be this guy right here. So a 0 over 1, so at pi, I'm sorry, at 0 radians, or over here, this would be a 0 over a negative 1, and this is pi radians. So 0 and pi are the places where tangent is not going to work so good. No, I had it right. What am I doing? What am I doing? Boy, this is one thing that not being in the classroom is throwing me off a little bit. Let's put all that back. Yeah, this is totally okay. Yeah, because my x value right here is 0. I'm sorry, I had it off. You'll see that I have the coffee. It hasn't all gotten in yet. My apologies. What x and y relationships are impossible? We can't divide when y is equal to 0. Y is equal to 0 right here and over here. Unfortunately, that now gets to live on in YouTube forever. So what are those two values, right? I'm going to either be doing a 1 over 0, which would be 0 radians, or a negative 1 over 0 right here, which would be a pi radians. Both of those places are spots where cotangent's not going to exist. Cosecant, right? You might remember some of these graphs from EO6. We made you make a few of these sort of things. Does every x value have a y? Nope. We can see plenty of places right here where we have these asymptotes. There's an x value where I don't get a y value out. So this one, no, that's a little weird with that. Does every y value have an x? This is also no. Look right here. If I drew a line right here at like negative half, does my cosecant graph ever hit? It doesn't. So like, let's ask what are some restrictions for this here? Well, anytime y would be 0, well, this graph isn't going to exist. So the same sort of undefined cases, those would basically be these asymptotes, 0, pi, 2 pi, right? Because that's where, at those places, my y value for like sine is 0. It also doesn't exist. I'm going to write out the range for this guy. Let me type this out. We can do it this way. We'll just write it. If r over y ends up being less than a 1, this is impossible. Right? Because think about it. If we're doing a right triangle, your r values, your hypotenuse, that has to be the biggest. If this is a bigger number than this guy, how can it ever be less than 1? It doesn't work. These are the situations where this is impossible. It's allowed to equal, right? At the bottom or tops of those curves, it does actually hit those things. This is a situation that's going to be impossible, though, right? Anything in between 1 and negative 1, cosecant can never get to. Secant's going to be the same sort of deal as well. Does every x have a y? No. We have these multiple asymptotes here. Does every y have an x? Also no. The same sort of reasoning, right? None of these y values in here secant ever hits. So places where cosine exists, secant does not, because they're reciprocal functions. What sort of relationships are impossible? It's the same idea. The ones that are impossible are going to be times like this, where r over x is less than 1 and greater than negative 1. This can never happen. All right, let's actually put some of this stuff to use here, okay? Which of these questions are going to have like numerical answers, meaning just as you look at it, could it work, yes or no? Sine of 90, yeah, we know what that looks like, right? We're going straight up on the unit circle. We can do that, no problems. Can I put negative 4 million degrees into cosine, basically go backwards on my unit circle a lot? Sure, no problems. Tangent of pi over 4. That's another known unit circle value one. Not a problem. If I do tangent of 90, it's a known unit circle value, but does it have a, but if we're going straight up, right, that's going to be a 1 divided by 0 situation. That doesn't actually work. So it doesn't have a numerical answer, even though we can answer a question with this because we know our unit circle. We're getting to some weirder calculatory ones here, like does this exist? Can sine ever be 0.33498? Yeah. Sine goes between a 1 and a negative 1, so this is in that range, no problems. Can cosine ever be a 1.28? No. Cosine's also going to go between a 1 and a negative 1, so it can't ever go outside of that. Can tangent ever hit 0? Yeah, it sort of starts off right at 0 and pi, tangent's going to be 0. Can tangent ever get 17.34? Yeah, we said that tangent can get any value in the world you want, but there's some x values it doesn't exist at. Now, which of these sort of things could be done without a calculator? You could do sine of 90 without a calculator, no problem. Could you do this one? Absolutely not. That's so many revolutions of a unit circle, we have no idea. Need a calculator for that. We're showcasing which ones would, because you might see a question or two on your quiz, but we're not going to make you use any calculators for that. Could you do tangent of pi over 4 without a calculator? Sure, it's a known unit circle value. Tangent of 90, even though its value doesn't exist, you could tell me that it doesn't exist without a calculator. What about sine is 1/4? That's not a known unit circle value. We need a calculator. Do we know times where cosine is equal to half? That's a known unit circle value. Yeah, we can answer this one without a calculator. What about tangent 0? Another one. We know those times. I'll go back and clarify. Cosine is going to equal half. And I'm thinking on my unit circle, where is my x value going to be half? So it's going to be in quadrant 1 and 4 because it's positive. At quadrant 1, this would be the pi over 3 guy. Pi over 3, like ask yourself, what's cos of pi over 3? 1/2. What's that same basically angle as pi over 3 in quadrant 4? That's a 5 pi over 3. Can cosecant of x equal 2? Absolutely. The range that it can't get is anything between a 1 and a -1. It can go from 1 to infinity or -1 down to -infinity. Do you know it without a calculator? Yes. Because, think about this guy right here. This is effectively, if I turned this into sine, the reciprocal, I'm flipping this. 1 over cosecant is sine. So if I flip this, I would get 1/2. We know that. That's a known unit circle value. So, let's go a little further. If I asked you for something like this, where is sine of theta equal to 1/5? This is a calculator one, and I'm going to showcase a little bit what's happening just to try and make sense of this. First, it does exist, and every question we're going to ask for your quiz is going to be between 0 and 2 pi. We're not, if we were in class, we would do a whole lot more with this, but right now, that's everything that you're going to look for is within 1 unit circle revolution. That's it. So how would you actually figure this sort of thing out? Well, I would need to undo this piece right here. So I have sine, I'm going to try to, oh wow, first try. Doesn't normally work so clean. I'm going to do a 1/5 sideways just to make this a little clearer. What I have to do to undo sine, you've probably seen some of this stuff before from Math 3. I'm going to take the inverse sine of both sides. What that would look like would be this. And if I did this whole piece here, I copy it over onto this side. The reason we do this is the inverse sine of a sine, come on, is going to cancel. So really, what are you going to get? It's going to look like this. This is something you're going to need to type into your calculator, okay? I'm going to do this. Maybe. Pull up the calculator here. If I can find it. Okay, here we go. I'm going to do this one in degrees just to help make sense of what's going on. Normally, you know we're big fans of radians, but this is going to make a little more sense. If I typed inverse sine of 1/5, so that's giving me 11.5 degrees. So here's what that means, is that right here, that's where we're going to call that my 11.5 degrees, okay? But you've got to be real careful in this version of like EO7 where we flip it, there can be more than one answer. If we're asking where is sine equal to 1/5, there's 2 places. If this y value right here is 1/5, if I went all the way over here, this guy, this same angle, well, it's not the same angle. That 11.5 degrees back from 180 is also going to give me the same y value. So you could do 180 minus 11.5 to figure this angle out. The big thing is understanding, is there more than one answer? That is going to be a huge thing. Fake answers on the quiz, which I took, are going to require you to know that a lot of these have more than one answer. Be very careful with that. Okay, let's get to the actual sort of like algebra for that. If I ask you to solve something like 2x plus 3 equals 4, right? We're going to come along, we're going to subtract a 3 from both sides. It's going to give me 2x equals 1. I'm going to get x equals 1/2 after dividing both sides by 2. What are you really doing? Isolating the variable, right? We're undoing steps here. All of that sort of thinking that we just did is going to be the same, except now we're going to isolate the trig. So if I gave you this piece right here, I'm going to highlight one portion and show you how it's not super different. If I look at x, what are you chewing on, Obi? Come here, bud. Hey, stop it. Come here. You don't need to destroy that. No. Come here. No. Thank you. Just leave it alone. You're fine. Sorry, little dog is chewing on some stuff. It's a downside to a puppy. Okay. The algebra is basically going to be the same. Watch this. If I isolate the trig, I'm going to subtract the 3 from both sides. So I'm going to get 2 sine x equals 4. What would I do next? I didn't subtract, did I? Nope. No, I didn't. 4 minus 3 is 1. Don't get stuck on the hard stuff, huh? That would be 2 sine x equals 1. If I divide both sides by 2, I'm going to get sine of x is 1/2. This is now the style question that we're going to give you. Your quiz will absolutely have something that looks like this. And you're going to repeat all that algebra. Isolate the trig to get there. Once you're at this stage, here's where you got to sort of turn on your brain and be like, do I know my unit circle? Where are the times on the unit circle where where sine is going to equal to 1/2? Well, we're looking for positive places. So I'm looking for quadrants 1 or 2 for positive y value. I'm really looking for this angle right here and this angle right here. What are those places where the y value is 1/2? This guy right here is a pi over 6, and then this one is 5 pi over 6. So really what you're doing at this point is you're taking the inverse sine of both sides, like I sort of showed in that previous step. We're asking this. And if you type this into your calculator, it's not going to give you both of these. There's a lot of nuance around how this works, which is why you have to know the unit circle. It's only going to give you this pi over 6 guy. I'll show you. If I did inverse sine of 1/2, so 0.5, oops, got a little too large there, we get 30 degrees, which is pi over 6. Now, it doesn't matter how many times I do that, it's not going to give me 5 pi over 6. There's a lot of stuff with like how inverse trig functions work, and they only exist for like 2 quadrants and things like this, which is why you have to be smarter. You can't just jam this stuff in a calculator. We're going to expect both of these answers. Think, when you have this question right here, I look at this as asking, when is sine equal to 1/2? Okay, if it helps to do the inverse, cool, that's kind of what we're doing, but there's more than one answer, and the calculator is never going to give it out. If you want to see what that looked like in radians, change it back just to showcase. It does work, but it's still only going to give you 1. Hey, what is that number? Hold on, let me type pi divided by 6. Hey, it's the same number, right? So it's telling you in radians, it's pi over 6 radians is where that happens. It's never going to give you the 5 pi over 6. You've got to be a little smarter than the calculator. Okay. So we're going to work through the algebra of a few of these. Where are we at time-wise? Okay, we're all right. So use symbol sense to determine if the equation has a solution. This is going to be one of the skills we're going to want you to see. Your first step, isolate the trig. I'm trying to get cos x by itself. Consider that your variable. I'm going to subtract square root of 3 from both sides, which is going to give me 2 cosine of x equals the square root of 3. If I divide both sides by 2, I'm going to now get cosine of x equals square root of 3 over 2. Find 2 exact solutions and, oh, can this happen? Yeah, square root of 3 over 2 is like a 0.87 sort of thing. You should also hopefully recognize that as a pretty common value. We're not going to tell you between 0 and 360. We're going to say between 0 and 2 pi radians, right? The whole thing is going to be in radians, but it's the same idea. When does that happen? If I were to think on my unit circle, when is my cosine value going to be positive? Boy, this is a circle here. When is it going to be a root 3 over 2, which is the real big value? It's going to happen right here at pi over 6 and 11 pi over 6. Again, if you got a unit circle, take a look at it. You're going to see cosine of pi over 6 and cosine of 11 pi over 6 both give you that root 3 over 2. This would be some cool stuff that we would have done if we're in class, but you're getting a slightly easier version of EO7 right now, so we're going to cut that stuff. All right. Hey, if we ask you to solve something like this, how would it go? I'm going to add a 2 to both sides, which is going to give me 3 sine of x, because your first move is you got to even see if it's realistic. 1 plus 2 is 3, correcting my silly mistakes from earlier. I'm going to divide both sides by 3, which is going to give me sine of x equals 1. Can this thing happen? Can sine ever be a 1? Absolutely. That's the maximum it gets to. When does sine get to 1? Well, on my unit circle, that's going straight up. At pi over 2, that's the only time. This one happens to be 1, right? Because on my unit circle, that's the highest point. There's no other point that it goes to 1. There you go. Let's work through a few more. Something like this. 5 cosine of x plus 1 is 3. Again, isolate the trig. Get this guy by itself. Subtract a 1 from both sides, which is going to give me 5 cosine of x equals 3 minus 1 is going to be a 2. Divide both sides by a 5, which is going to give me cos of x is 2/5. Now, we're not going to make you tell us the angles. In class, if we'd been together, we still would have. In this case, we're just going to ask, could this sort of equation, this original equation here, does it have an answer? It does. Cosine can go between a 1 and a negative 1. Totally valid. Like, it does have two answers, right? It's going to be something in quadrant 1 and something in quadrant 4 because it's a positive x value that we're looking for. What about this guy? Let's see if we can either solve it all the way or just tell if it would have an answer. I'm going to add a 3 to both sides, which is going to give me 2 cotangent of x is going to equal now 5. I'm going to divide both sides by 2. Cotangent of x is 5/2. That's not a known unit circle value. Does it exist? If we asked a question, does this equation have solutions? Absolutely. Remember, cotangent can give me any y value I ever want, so this happens. It doesn't really matter what the input variable is. I know it says x right here. You can call it theta. The idea is, can cotangent as a function give you 5/2? Yes, that's totally valid. Okay. Must have missed this one. Sorry, I don't know when that question was there, Liv. My apologies. Maybe you were answering another one. We'll get to some of that. Okay. Could this equation have an answer? If I were to divide both sides, secant of x is 2/3. It's not a known unit circle value, but can secant be equal to 2/3? No. Secant basically, that's the range that it can't. So where cosine exists between 1 and negative 1, secant does not exist. Right? My secant graph is going to look like one of these guys. And 2/3 is going to be right here in the middle. Not going to work. So back to this question from sort of the very beginning. Okay? If I gave you the following equation and we said, hey, solve for x between 0 and 2 pi. I'm going to add a 1 to both sides, which is going to give me, 2 cosine of x equals 1. I'm still isolating the trig. I'm doing algebra to get just the trig function. I don't care about the thing on the inside, but on its own for now. Divide both sides by 2, which is going to give me cosine of x is 1/2. Ask yourself, can that happen? Can cosine of x equal 1/2? Well, it can, yes. We know that cosine is going to go between a 1 and a negative 1. Is that a known unit circle value? Can we expect you to figure out where that is? Absolutely. Where is cosine of x going to equal 1/2? We're looking for a small x value, so that's going to be in quadrant 1 right here at pi over 3. Oh goodness, that's not my best 3. But you got to be careful. This happens, cosine's positive in 2 places, quadrant 1, quadrant 4. you've also got to have this guy right here. This is going to be 5 pi over 3. So I'm going to expect two answers. What would you say your answer for this is? X equals pi over 3 and 5 pi over 3. Again, if you typed inverse cosine of 1/2 into the calculator, I'll show you what it's going to do. I think we're still on radians here, so let's do 0.5, because that's my 1/2. It gives me this funky number. I'm going to show you that's really pi divided by 3. It can only spit out 1. Now I'm going to show you that if I did cosine of pi over 3, does it give me 1/2? Absolutely. So that's one of the answers we're looking for is pi over 3. But the calculator is never going to be able to spit out this answer. I'm going to verify that if we do 5 pi over 3, do we get 0.5? Yes. Be very careful about this unit circle symmetry. And I'm going to hit some of that sort of stuff in the other video, going over some speed quiz things tomorrow. For now, let's finish this guy out and get you on with the rest of your day. Here's how I would build some of these test questions. I would take a known unit circle value. 1/2 is something that I know cosine can get to. So I'm taking that same previous question base, and here's what I would do. Let's start off by making it a reciprocal. Okay? If I took the reciprocal of cosine, that's secant. What's the reciprocal of 1/2? Flip that, that's 2 over 1, which is 2. Well, okay. Now, I'm going to do a little bit of algebra to both sides. If I double both sides, I now have the equation 2 secant of x is 4. Now understand, this all started from, I know that this thing is a piece of information you guys know. Or if we know the unit circle, it's something we should know. Where is cosine equal to 1/2? We just answered that question. But how would I basically take it a little bit further? Again, I'm going to turn it into its reciprocal function, so I flip that fraction. I doubled both sides. Let's add a 3 to both sides, right? That's just valid algebra. I'm adding a 3 to both sides right here. This is how I would make a test question. So that's really going to turn into 2 secant of x plus 3 is 7. Solve for x. If I gave you this problem right here, which could very well be a test question, right? I just made this sort of thing up. But if you came across one of the questions on your quiz on Friday and it said, hey, solve for x, what would you do? We're going to do the same thing we've been doing all along. I'm going to isolate the trig, so I'm going to subtract a 3 from both sides, which is going to give me 2 secant of x equals 4. I'm going to divide both sides by 2, which is going to give me secant of x is 2. And then I've got to think, hey, can secant of x equal 2? Absolutely. Is it a known unit circle value? This might be a little hard for you to answer. I'm not the best at thinking about unit circle values for secant, cosecant, and cotangent. What I like to do is I think, okay, well, secant is the reciprocal of cosine. So I'm going to turn this guy into cosine. Right? Do you remember this thing where 1 over cosine equals secant of x? Well, if I'm basically turning this guy by doing its reciprocal, so what I'm doing is basically 1 over secant, I need to flip this guy as well, which is where this is 2 over 1. That's where I get 1/2. Can you now answer this question? Do you know where cosine of x is 1/2? We just did that on the previous slide. That's how I'm going to do these problems. I'm going to isolate the trig. I like to turn it back into sine and cosine and tangent because I know those much better on my unit circle. If you know your inverse trig or your reciprocal trig, secant, cosecant, cotangent that well, great. You might get to here and be like, oh, yeah, it has to be pi over 3 and 5 pi over 3. Great. My brain doesn't work super great that way. I'm going to show you how I would take the same base question from 2 slides ago. This idea where cosine of x is 1/2 and ask, this is a fact that we should know. At pi over 3 and 5 pi over 3, if I put both of those into cosine, it's going to give me 1/2. Right? It's a very small x value, but it's positive. Quadrant 1, quadrant 4. If I didn't want it to work, I might still do the reciprocal and turn this into secant, but not do this. Again, this is one, if I'm building a question for your quiz that was not going to work, this is what I would do. I didn't do the reciprocal of this side, but I did for the left, which here's where the problem's going to be. I'm going to repeat those same steps last time. I'm going to double it, which is going to give me 2 secant of x is 1. I'm going to add 3 to both sides. which is going to turn into now 2 secant of x plus 3 is 4. And we might say solve for x. One of your multiple choice answers. We already know this one doesn't work, right? Secant of x can never get 1/2. I intentionally made that mistake to build this question. If you're taking this test on Friday, what would you actually do? Same algebra. Isolate the trig. We're going to subtract the 3 from both sides, which is going to give you 2 secant of x. Again, this is just some variable. It's easier for me to do x's instead of the thetas. 4 minus 3 is a 1. Divide both sides by 2. I'm going to get secant of x is 1/2. And then you have to ask, does this sort of thing exist? And maybe at this point you're like, I don't even want to mess with it. Turn this into cosine. If I turn secant into cosine, I'm doing the reciprocal. I'm flipping it. Meaning I'm going to flip this guy right here. Is cosine, can it ever equal 2? Like, is this a true thing? Absolutely not. Your answer for this question would be no solutions. So, I promise there were no Star Wars jokes. That's all I've got for you for now. Tomorrow, later probably in the afternoonish, I'm going to do another video covering a speed quiz, some of the thinking, and how I would also maybe take a few of these questions and work backwards. There's multiple speed quizzes all posted on Google Classroom. They are recommended. It's basically going to ask you just, do you know the unit circle outright cold? So it's going to ask you parts where it's already in this right here, this bit of red. It's going to say, hey, where is cosine of x equal to 1/2? That skill is critical because by the time we throw algebra on top of it and make it, right, this, again, understand these two pieces here, cosine of x is 1/2 and 2 secant of x plus 3 is 7, are the same question. There's a little bit of algebra you have to do on the right side to get to this cosine of x is 1/2 point, but they ultimately get there. So if you can't answer the question, where is cosine of x equal to 1/2, because we're missing some of that unit circle stuff, go through some of those speed quizzes. Again, I'm going to make another video tomorrow. It's not required viewing. It's maybe perhaps recommended. Okay, with that, I'll bid you farewell, and we'll see you sometime in the future. Take care.